The Sahara Desert is one of the most sun-exposed places on Earth. The desert covers an area of 9 million kilometers squared and absorbs about 22 million terawatts of energy that comes directly from the sun per year. As you can see, covered the Sahara Desert with solar panels would solve the energy problem of humanity. Apart from the fact that we don't need that much energy, there are other reasons why this would not be a good choice. Today, in this video by aTech, you'll be able to discover all of them. Did you know that the Sahara Desert receives more solar energy than the planet can consume? Indeed, every day the temperature of the sand of the Sahara Desert reaches 80 degrees Celsius. According to the NSA, each square meter receives an average between 2,000 and 3,000 kilowatts of solar energy in 1 year. So, if we installed a solar farm covering the entire desert, this farm would produce more than 2,000 times more energy than most efficient power plants in the world, which produce about 100,000 GWh per year. Let's see how solar energy works. Photovoltaic production is a widespread method of energy production. This basic principle of this production is the transformation of the sun's rays into electric current by means of solar panels. Electricity is generated when electrons start to flow in the same direction. When the sunlight hits the surface of the panel, the photons transmit the light energy to the electrons, which agitate, and when they return to their place, they produce electricity. However, the generation power of the panels is limited. The solar panels do not react with all of the light frequencies, which prevents the conversion of more than half of the absorbed light. There are also free convertible protons that do not reach electrons. But today, thanks to research, solar panels are able to capture more and more electricity thanks to the anti-reflection coatings and these drawings, some of which seem harmless, drawn to the surface of the panels. As a result, the possibility for photons to hit many more electrons has increased. These techniques also increase the sale of solar panels from 10 to 25%, and the experimental model have already reached 47%. In addition, the price of solar panels has dropped dramatically over the past decade. According to the International Electric Agency, the price of solar panels has dropped by 89% in 10 years. The solar megawatt hour costs either 2 or 3 times less than gas or coal, and it is to say that solar energy provides the cheapest electricity in history. It is also their flexibility that has made solar panels so cheap. They're easy to install and easy to upgrade. Plus, when they produce energy, the panels do not emit CO2. Solar energy is renewable energy that does not consume fossil fuel resources. It should be noted that countries such as India, China, Egypt, and the United States have already experimented with implementing of panels in the desert. Called solar farms, they harness the sunlight energy to create clean, renewable electricity. They measure between 15 and 56 kilometers squared. When the sun reaches the zenith, they are able to produce electricity for hundreds of thousands of homes in the regions. However, in these production centers, the level of heat is intense, and this unconverted light greatly reduces the profitability of the panels. Some scientists say that the panels can only convert a small amount of energy they receive from the sun. A substantial and energy-intensive cooling system is required to support the needs of these arrays and maintain optimal temperatures. Even with these systems, solar panels in the desert absorb a considerable amount of heat, more than the natural sand environment. At the moment, given the size of these farms, they do not represent a real danger. But if we even try to cover the entire Sahara with solar panels, the climate of the region would be greatly affected. By covering the desert completely, it will cause an increase of ground temperature. The heat generated will increase the humidity levels in the air, which will cause rain to fall, thus transforming the desert as we know it. Moreover, the construction of these solar farms in the desert has already disrupted local ecosystems. Imagine then the effect of such a huge implementation would have. It would literally transform the desert landscape. The excessive heat generated by the solar panels in the desert would alter airflow, affecting the weather system in various parts of the Earth. Even if 1/5 of the Sahara was covered in solar panels, the increase of global temperature would affect the popular regions and expose the sea more to the melted ice. According to a simulation, it has been shown that if we cover the Sahara Desert with 20% of solar farms, the local temperatures would increase by 1.5 degrees Celsius. If we go to a coverage of 50%, we note an increase of 2.5 degrees Celsius. So the temperature of the planet would increase by 0.16 degrees Celsius for a coverage of 20 and 0.39% degrees Celsius for a coverage of 50%. In addition to the simulations and experiments, they'll be able to find other solutions to associate with solar panels to obtain better results. A new approach then considered the giant mirrors. Thanks to these mirrors, it'll be possible to have a concentrated solar farm. The implementation of the Noor electricity production project in Morocco covers about 30 kilometers squared of the Sahara. It is a concentrated solar farm. It is a part of a project that aims to produce 42% of the country's electricity needs. With the infrastructure installed in this farm, mirrors capture the sun's rays and point it to generate a very high temperature. The light reflects on a sensor that converts the energy into heat and then into electricity. The potential of concentrated solar energy is enormous. In theory, only 10,000 square kilometers of the Sahara could supply all the electricity the world needs. As a negative consequence, these mirrors can have serious impact on wildlife due to desert temperatures. One of the greatest weaknesses of solar energy is the fact that it can only be used during the day, contrary to these plants that continue to produce electricity even after dusk. This is due to the fact that the cooling of the materials takes time. On the other hand, whether it's the panels or the giant mirrors, the respective farms can be easily integrated into the existing infrastructure. It is especially the transport outside the premises that is of great concern. Transporting energy over large distances is very expensive, and this can lead to a loss of power of up to 10%. For the time being, some countries are still trying to connect their power grids around the world. Many farms practice energy storage by means of massive batteries, or they convert electricity into clean gas to be better used later. The problem with these technologies is that the return is not proportional to the cost. From an environmental standpoint, these industrial renewables sometimes have those problems that we see from fossil fuels because they're also based on destructive mining or carbon-producing global supply chains. There are other smaller solar farms that supply and power individual buildings or rural communities. These projects provide renewable energy in remote areas where there is no grid. According to Peter Diamandis, we live in a world that receives 5,000 times more energy than we consume as a species in a year. To keep up and meet humanity's energy needs, we need to provide solutions at both small and large scales. Here we are at the end of our video. More than a few of you have opinions on the subject, so feel free to leave us a comment to let us know. Let us know if you think it's possible for such a project will ever become a reality. Don't forget to leave us a little blue thumbs up to let us know your appreciation. Share the video with your friends to make sure you don't miss our next videos, subscribe, and especially activate that notification bell. Goodbye friends, and we'll see you soon.